This is the notes for all transformations. The directions say describe the transformation or combination of transformations that map the triangles. Okay, so keep in mind this combination means it could be rotation, reflection, translation, dilation, or it could be more than one of those put together. Okay, so let's start with ABE. So that's right here. This one is ABE. And we're going to triangle EFH. So here's E to F to H. Okay. So the first question I'm going to ask myself is, did my triangle stay upright? And it did. What was in the top corner is still in the top corner, right? It didn't get flipped, it didn't get turned on its side. This top corner stayed, and it simply slid over here. So our first one is a translation. Okay, simple enough. It stayed the exact same size, and it remained upright. It just moved from the top left to the middle. My next one is BCF to IHF. So BCF, B to C to F, that's right here. And then we're going to I to H to F. So here's I to H to F. There's I to H to F. Okay, so this time I'm asking myself again the same question. Did it remain upright? What was my top corner? Did it slide across and stay the same top corner? No, it did not. It actually got turned all the way upside down. So we would say that this one is a rotation. So here is my common point, and that spun 180 degrees upside down on itself. Okay, keep in mind it is not a reflection. Okay, if it was a reflection, it would have came down here and it would have been backwards. Okay, so if I did a rotation, that spun it all the way upside down. Next, we'll try HIJ. So here's H to I to J. It's in my corner there. And we're going to F to E to B. So here's F to E to B. So this time I went from this corner to all the way up here. So I know it's going to be a translation because it's moved, it's not attached to it anymore, but it also got flipped upside down, right? We're asking ourselves that question of, did my top corner here stay in my top corner? So from HIJ, translation would be to EFH, so it slid across, but then it also got turned upside down. Okay, what could be helpful is you could also draw another one right here. So we could see a little more clearly the HIJ, I spun it around and I slid it over. So the order doesn't matter, but I do need this sequence because it's a combination. I do need both of those transformations. This one was a translation and a rotation. Okay, so I spun it and I slid it over. The order doesn't matter. I could have also slid it over and then rotated it right here, directly almost on top of itself. Okay. There's two things I'd like you to add to this section. The first one, let's look at one more, HIJ to ADJ. Okay, so here's HIJ, H to I to J, remember was that small one. What about then if I go to ADJ? Well, ADJ is that entire picture. Okay, there's one other transformation we haven't talked about yet. The one that makes it larger, remember we compared it to scale factor, but our vocab word we gave it this time was dilation. Okay, so just know that it is possible as well. If your project is perfectly symmetrical, I would also see a dilation. So as I'm doing my rotations and my translations, if that same shape matches, it can also get bigger, and then I would see a dilation as well. Okay. The thing that cannot happen though, with the way my picture is set up right now, is I can unfortunately not have a reflection. Okay, if I did a reflection, that would flip it this way, and then my pattern wouldn't keep going. Okay, so just keep in mind, if your picture looks like this, it's only a translation or rotation. In order for a reflection to happen, I'd have to have that same piece flipped back over, and then now my triangle is facing the other way, so it didn't have to keep up with my pattern. All right, let's go ahead and look at that last example then. So it says determine whether the polygons are similar. If they are, what's the sequence of transformations? Okay, so again, we're asking ourselves, did it stay the same? Is my long side still my long side on the right side of my picture? Or is my short side still on the bottom? Well, my short side is still on the bottom, but this longest side has now got flipped over to the other side. So if I drew a line here in the middle, my shape got flipped from this side to this side. Okay, so we would call that a reflection. But then I need to double check. Do I still have a scale factor? In which case it would be a dilation. And then I'm also going to look at my angles. Okay, so we're starting with the idea that it's a reflection. It got flipped over. Is it a dilation? Did all my sides get times by the same thing? Well, if I'm going from 6 to 3, that's going to actually make it smaller. And we're going to say take it times 1/2. From 4.4 to 2.2, that's also half as big. From 2.8 to 1.4, that's also half as big. So yes, this is a dilation. My scale factor is 1/2. Everything got shrunk. Okay, and it was a reflection because it got flipped over. However, there's one thing, huge thing we're missing to say that these two are similar. It is a no. Okay, I'm looking for, what am I missing? I'm missing those angles. Do I know if angle U is the same as angle R? Unfortunately, I don't right now in my picture. Right? Or do I know if angle Q is the same as angle T? Unless they have that little symbol that shows this angle Q is the same as this angle T, I cannot say that they're similar. Or my last one, remember P with S. There's nothing to show me that this one is the same as this one. So unfortunately, no, those are not similar. Not with 100% certainty. It appears as if it was a reflection and then they did a dilation. They made it twice as big. But without knowing those angles, we can't say for sure that those two are similar.